Hello gentlemen, welcome to our video on solution stoichiometry. This is an example problem behind me for section 4.6, which you'll encounter in class. I'm going to go through how to approach this type of problem and how to put all the concepts we've been working with together to complete one major task. So our problem is a solution, or 100 milliliter solution of aqueous 0.250 molar lithium carbonate is mixed with a 250 milliliter solution of aqueous 0.130 molar strontium chloride. So we have two aqueous solutions coming together. This is a double replacement reaction. The first thing I want you to do is write a balanced molecular equation, complete ionic equation, and net ionic equation for this particular reaction. So we start out with our two aqueous substances. Lithium carbonate, aqueous, reacting with strontium chloride. We got those from our problem here. As we predict the products, we have to remember that these are ionic solutions or ionic compounds in solution. They are going to completely dissociate. So we have Li plus and Cl minus coming together to form lithium chloride. And then we have Sr2 plus and Cr3 2 minus. Sorry if you can't see that, it's a little light there. We have Sr2 plus and CO3 2 minus coming together. Those charges cancel out, giving you SrCO3. Lithium and chlorine are aqueous in solution. They are soluble. Strontium and carbonate are insoluble. It forms a precipitate. So this is a precipitate reaction. And when we balance it, we get a coefficient of 2 there. My complete ionic equation is taking these aqueous solutions, taking them apart. I have two lithiums here, Li plus, aqueous, one carbonate, CO3 2 minus, and it's aqueous in solution. I have one strontium, Sr2 plus, that's aqueous, plus two chloride ions, aqueous, creating two lithium ions that are still in solution, and two chloride ions that are still in solution, plus my precipitate, strontium carbonate. This is my complete ionic equation. And I get rid of my spectator ions, which in this case are lithium and chlorine, so Li plus and Cl minus. I take those out of my equation, and it leaves me with my net ionic equation, which is strontium 2 plus in aqueous solution reacting with carbonate in aqueous solution, creating solid strontium carbonate. That's my net ionic solution. That's letter A. Now let's take this, remember it. For letter B, we actually start the stoichiometry process. So calculate the mass in grams of the precipitate formed. Our precipitate was strontium carbonate. We have to first find a limiting reactant. Now remember, here's our chemical equation here. This is my molecular equation. I have 100.0 milliliters of a 0.25 molar solution of lithium carbonate and 250 milliliters of a 0.130 molar solution of strontium chloride. So my first steps in finding my limiting reactant are to relate this compound to that compound and say, well, if all of my lithium carbonate was used up, how much of my strontium chloride would I need? Or you can do it the other way around. We're going to do it this way. Now we can use our volume and our molarity to figure out the number of moles of this particular compound. Here's how we would do that. So we start out with 100 milliliters of this concentration of my lithium carbonate. But we know that big M here, molarity, stands for moles per liter. Our volume here is in milliliters, so we're going to convert that to liters. For every 1 liter, we have 1,000 milliliters. That cancels out. Now I have liters. I can use this volume of liters to convert my moles per liter here in my molarity to just simply moles. I do this way. I multiply times my molarity. So 0.250. This big M stands for moles per liter. If you notice, liters and liters will cancel out. And just to be clear, this is lithium carbonate. So my liters and liters cancel out. Now I have moles of lithium carbonate. So now that I have moles of lithium carbonate, I'm actually going to solve in the intermediate step here. So I have 100 divided by 1,000 times 0.250. That would give me 0.0250 moles of lithium carbonate. So 0.0250 moles of lithium carbonate. I want to figure out how many moles of strontium chloride would react with this amount. So I do stoichiometry. I use my mole ratio to relate the two. It's a 1-to-1 ratio that I got from my equation here. So for every 1 mole of lithium carbonate that I use, I will also need to use 1 mole of strontium chloride. Moles of lithium carbonate cancel out, and my number of moles stays the same, 0.0250 moles, but we're talking about a different compound now, of strontium chloride. So this is saying, if all 100 milliliters of my 0.250 molar solution is used up, if all 0.0250 moles of lithium carbonate are used up, I will need to use 0.0250 moles of strontium chloride. Now to figure out which one's a limiting reactant, we have to figure out, well, how much of my strontium chloride do I have in the first place? So I do the same thing with my strontium chloride. I can figure out the number of moles by using the volume and the molarity. So, finding my limiting reactant, I'm still in the process here. So I take my 250 milliliters, I convert it to liters. For every 1 liter, I have 1,000 milliliters, so I have units in liters now. And I'm going to multiply times the molarity, or the concentration, that's in moles per liter, in order to figure out how many moles of strontium chloride I actually have. And this is strontium chloride that we're dealing with now. So my liters cancel out. When I do my math, 250 divided by 1,000 times 0.130. It's 0.0325 moles of strontium chloride. So this is how much strontium chloride I had to begin with. This is how much is used when lithium carbonate is gone. So I have this much at my disposal. This is how much is used. So I will have some strontium chloride left over, meaning lithium carbonate is my limiting reactant. So this is my limiting reactant. And go back over that yourself if you need to verify why that's the case. So now to answer my question, calculate the mass in grams of the precipitate formed. So in order to calculate this mass of precipitate formed, I have to use my limiting reactant to figure out the mass of strontium carbonate, which is my precipitate that will be formed. So I start, same place I started here. I have 100 milliliter solution of my lithium carbonate. I want to get that into units of liters. I want to figure out how many moles of lithium carbonate I have so that I can use the mole ratio to go between moles of lithium carbonate and moles of strontium carbonate. So I multiply times the molarity here, 0.250 moles per liter. This is of lithium carbonate. My liters cancel out. Now I want to relate moles of lithium carbonate to moles of strontium carbonate. I do so using the mole ratio. So the mole ratio is still 1-to-1. So for every 1 mole of lithium carbonate, I'll produce 1 mole of strontium carbonate. Moles of lithium carbonate cancel. Now I have moles of strontium carbonate. The question is asking for the mass in grams, so I have to go from from moles to mass. I do that using the molar mass. So for every 1 mole of strontium carbonate, I will have 147.63 grams of strontium carbonate. Now I can solve. I multiply this out. 100 times 0.25 times 147.63 divided by 1,000, and I get 3.69 grams of strontium carbonate. That is how much of your precipitate has been produced at the end of that reaction using your limiting reactant. Now, go back over that if you need to. Last question, part C. Everything else has pretty much been reviewed as far as stoichiometry is concerned. This part's a little new. So calculate the concentration of all ions that are left in solution. This includes your spectator ions and the ion that was a part of your excess reactant that was not used up. In our next video, which will be right after this, I'll go over how to do this problem.